Alright, good morning everyone. Today we are going to take a look at how to program the MicroDev ESP32-S3 through the Arduino IDE. So this is going to be quite a short video and will show you how simple and easy it is to actually program one of these things. So we are in the Arduino IDE, and the first thing you need to do is to download the board package for the ESP32 microcontrollers if you don't already have it installed. You do this by pressing the board manager, and in the search field you'll search for ESP32, and in here you'll find one from Arduino and one from Espressif themselves. We're gonna use the one from Espressif themselves. If you're not able to find this when you're searching in the board manager, you might have to go into File, Preferences, and here under Additional Board Managers URLs you will have to copy in this link here, and after that the ESP32 board package from Espressif will appear for you here. The link will be in the description of the video as well. Now that we have the board manager all set up, we can start by plugging in our MicroDev board to the computer via the USB-C port. So we'll take our USB-C port here and insert into the MicroDev, and then after that we'll go back into the Arduino IDE and we'll have a look under Tools and Ports, and there we should now see our ESP32 show up on one of the COM ports. In this case it showed up on COM port number 4, so we'll press that. And now the only thing we need to do in order to be able to program this thing is set the IDE up for our specific microcontroller, our specific ESP32 microcontroller. And to help us with that, we are actually going to revert back to our own datasheet, the MicroDev ESP32-S3 datasheet. And if we scroll all the way to the end here almost, we'll find the ESP32-S3 setup section here. And here we can see we're supposed to go into Tools and we're supposed to select our particular dev module here. So we'll go into Tools, we'll go in under Board, we'll say ESP32, and here we need to find the ESP32-S3 dev module. We'll press that. After that, we once again have to go into the Tools and set up the rest of the things needed for our microcontroller. So we'll go in here again, and now you can see we have a long list here of different options here to set. And first off, we need to set USB CDC on boot to enabled. After that, we can select our clock frequency. Here we can actually select any clock frequency we want, and we can see here also that Wi-Fi is only enabled if we have a clock frequency of at least 80 MHz. But we'll let it sit here at the default 240 MHz. After that, we can select our debug level. We'll keep this at none. We don't need any DFU mode. We don't really need to erase all flash before we upload a new sketch. And here events will run on core 1. We might come back to this in a later video. This is quite interesting, but we'll leave it like this for now. For the flash memory, we'll let it sit at quad SPI at 80 MHz. For the flash memory, we'll go in here and set it to 8 MB. Then for the JTAG adapter, we'll have to select the integrated USB JTAG. Again, the cores, we'll leave them as is for now. We might come back later to have a look at that. We're not going to enable USB on the go. And then we will have to select our partitioning scheme. And here we can see the default says 4 MB, where those 4 MB are split between the actual app or our code and the SPIF memory. SPIF memory is basically an internal memory that allows us to store images and whatnot. However, we do have 8 MB, so we could go with this option here, 8 MB, where 3 MB is going to be reserved for our application, our code, and 1.5 MB is going to be allocated for the SPIF memory. And after that, we do not have any PS RAM on this board, so this one we need to leave as disabled. Upload mode, we need to make sure that we have UART0 or hardware CDC enabled. Our upload speed here, we should probably bump up to 1152. This is sort of standard for the ESP controllers. And then lastly, USB mode, we need to make sure is set to, again, hardware CDC and JTAG. ZigBee mode is going to be left disabled. Okay, so now we actually need to write our code, or in this case we're actually not going to write that much code, we're going to use one of the built-in examples. In our datasheet here, we do actually have a short section here where we explain how you could upload the basic Blink program, where you have to change the built-in LED enum to 41, since we are using GPIO 41 as our built-in LED. However, we are going to go into Files, and we're going to go into Examples, and we are going to find Wi-Fi. And in Wi-Fi, we are going to select the Wi-Fi scan example, and it's going to show up here in a new window. Here we are, and in this new window we do have all of the settings saved as from before. And here we can see we have the Wi-Fi scan example. So this example will basically print out on the serial port or the available Wi-Fi networks that we find. But just to make this a little bit more interesting, we are actually going to add a little code snippet here that will allow us to blink the LED as well. And the way we're going to do this is we are first going to declare that our LED pin 41 is going to be an output. So we're going to say pin mode, and we're going to say pin mode. The pin number is going to be 41, and the mode is going to be a output, right? So now our code knows we're going to use pin 41 as an output. And then here in the main function, we can actually sort of take advantage of this long delay that we got here. Every 10 seconds we're going to scan for Wi-Fi. But what we could do here is actually toggle our LED. So we'll write digital write, and the pin we're going to write to is 41. And then we're going to do a little trick here where we're actually going to read the value of pin 41 and invert it. That way we're going to get this toggling functionality. So we're going to say digital read instead. And the pin again is going to be 41. And we need to remember to invert this. All right, that's it. All right, we are now ready to upload the actual code. So again, we'll just double check here in Tools and make sure we're on the right COM port. And we can see here, COM port number 4 is our ESP32. Good. If we press, we'll have to press the upload button. But also, before we do that, we need to make sure that the ESP is in its boot mode. And we do that by pressing down the boot button and also pressing down the reset button. Then we release the reset button and keep the boot button pressed. And then we can press the upload button here in the Arduino IDE. And then we might have to wait a while. ESP code usually takes quite some time to compile in the Arduino IDE. So we'll see here for how long we need to sit around and wait. And while we wait, as soon as we're being prompted with the connecting, we can actually release our boot button. If we don't do that, the code will not start to upload. As you can see here now, we release the boot button and the code is actually uploading. All right, and now that we're done, we're being told that we need to hard reset via the reset pin. So we'll do that. We'll press the reset button. And now our ESP starts to blink. And if we go into the serial port here, we can actually see that we are now spitting out the available Wi-Fi networks that we can find here. Great. All right, that's it. Thank you so much for watching, and I'll see you guys next time. Bye bye.